Hello Matrix, welcome back to another video. So please don't forget to like, comment and subscribe to the channel. We are still on organic chemistry, physical sciences grade 12. This is one of the first modules that you will be taught in grade 12 depending on what your educator starts with, but it's part of the first term topics. So guys, without wasting any more of your time, let's get right into it. So today we'll be dealing with naming the homologous series. Okay, so you're going to learn how to name them. If you are given a structural formula, you need to know how to name that structural formula. Okay, and then that will help you to know as well if you are given a name, if you're given a formula, an organic formula, how will you be able to know or what homologous series is this? Okay, so that's what we'll be doing. Please check the description box. I have linked the introduction to this video. I have linked another video where I go in deep details of functional groups. Yeah, so we know the 9 homologous series. Now what we're going to go into is to knowing how to name them. We know their functions and so forth, so check those links on the description box. Now these are rules of naming organic molecules. The first step is to identify the number of carbon atoms in the parent chain of the organic compound. So the parent chain, let's look at it. All right, let's look at this molecular structure. Okay, where we have, this is an alkane, we have 4 C's in the middle, and then we have H surrounding it. Okay, so those C's that are making a line, they can either go from top to bottom, like from the C's can go this direction, they can go this direction, it does not matter. Okay, but as long as the C's are making a line, we call this the main chain. Okay, this is the main chain. Remember, the C's that are going in order, they can even go like you can have a C, a C, a C. Let's do this, and then the last C here. Okay, it ends like this. Then here we'll just have H, and then we'll just have H, just have H. It will be surrounded by the H's like this. So this line of carbons, even if they end, that is still a main chain. Please just keep that in mind. That is the main chain. This is the main chain. That is the main chain. Remember, when you are given, you should know the main chain. Now this one here is no longer a main chain. It's not part of the main chain. If you can look at it closely, this is not part of the main chain. Okay, so we have C, C and C, and then we have another C here. It's not part of the main chain, but maybe if it was just like this, and then the C was here, and then this is H, then we'll be talking a different story. But as you can see that this other C is just in a middle. It's just a different branch like this. It's not part of the main chain. Okay, it's not part of the main chain. Yeah, so that main chain is also known as the parent chain. So we need to know the number of carbons in that parent chain. So if those carbons are 1 carbons, the prefix of that structural formula will be meth. If we have 2 carbons in the chain, it will be eth. If we have 3 carbons in the main chain, parent chain, that will be prop. The prefix is the first word. If we have 4 carbons in that chain, it will be but. If we have 5, it will be pent, and if we have 6 carbons, it will be hex. So we only be doing up to 6. You only be tested on 6 carbon organic structures. So you don't have to worry about that. You just have to know the 6 ones. It's something that you have to know, guys. So practice them, make some cue cards, and make sure that you know this by heart. So the step 2 is that number the carbons in the parent chain. So you have to know, identify the number of carbons in the parent chain of the organic compound, and the following prefix are used. So just you, by knowing the number of compounds in the parent chain, you will be able to know the prefix of that structure. So number 2, number of carbons in the parent chain. Start with the carbon at the end close to the functional group. If you watched my previous video, you will know the one that I'm going to link and say functional groups. Watch that, you will know what is a functional group. So functional group must have the lowest possible number. Let's look for example. So let's look at this butane molecular structure. This structure has only hydrogen and carbons, right? We know that is an alkane. And how many C's are in there? We have 1, 2, 3, we have 4. So that is but. Remember, 4 carbons, but from that table that I just shown you. So because it's an alkane, it starts alkane ends with an, so butane. That's why we have butane. So you look at the number of those structures. Okay, let's go back. Yeah, let's look at this other structure here. So what differentiates this structure, chloropropane, is that the functional group, it has C that has been bonded with Cl. You see at the end, the carbon is bonded with the Cl. Though this C and Cl bond, you see it's number 1. So that is how you start to number the C's. So you will start, the first one will be the one closest to the functional group. So this is what makes this structure what it is that Cl. Okay, that Cl is the functional group. C bonded with Cl is the functional group. So we start with that first C. Yeah, because it's at the end, that will be the first C. But let's look at this one at the bottom. The Cl is in the middle branch. Can you see it's in the middle C? So the Cl is being bonded with, has a double bond with the middle C. So we can either start from your left and say the C on the left is number 1, or we can say use as they've done in on the bottom. You see the C that is on the left hand side is number 1, then this one that has the functional group is number 2. So yeah, we just do the C that is closest to the functional group as number 1. Even at the bottom, because we just have 3 C's, this one is in the middle, we can do this one on the right as number 1 as well. So this is what it means. So the number 1 C should be the one close to the functional group. Okay. So it says start with the carbon at the end close to the functional group, and functional group must have the lowest possible number. So step 3 is to identify the functional group of a homologous series in the compound. So identify the functional group of a homologous series in the compound. So if you are given a structure, you should be able to know if it's an alkane, alkene, alkyne, alcohol, aldehydes, ketone, carboxylic acid, or an ester. So that's what you should know, so that you'll be able to know that what is this structure, so that you will know what the name of the structure will end with. That is a suffix. That is the end name. We did the prefix, what the name of that structure will start with, and suffix is what the end name of that homologous series will or organic molecule will end with. So for alkanes is AN, anything that ends with ANE is alkane. Alkenes is ENE, alkynes is YNE, Alcohols is OL, anything OL is alcohol. Aldehydes, AL. Ketones, 1. Carboxylic acid, ioic acid. It's oic acid. And then ester is 8, yes. So that will be another thing. That will be the end of the name of that particular structure. So for example, if you can look at these two structures, they just have carbon and hydrogen single bonds, so which makes them alkanes. And you see this one at the top has 4 carbon in the main chain, parent chain. So it starts with but for 5 carbons, and then it ends with ane. Ane meaning it's an alkane. And then the second one is here has meth meaning it has 3 carbons in the main chain, and then it has ane at the end, so it means it's an alkane as well. So the 2 that is in front, it just meaning that the other C that goes down is on the second branch. Okay, the first one on the left is the first one, the middle one is the second one. So it means that thing that is going out, the branch, we say that is branching out, is on the second carbon. So that's why we have 2 at the beginning, but with the first one there is no 2. It's because it does not have that C that is branching out. So when we talk about a C that is branching out, is and we have a C, a C, a C, like that, and then there's another C here. So this C here is the one that is branching out. It will have its own H like that. So depending on where it is, again, this is number 1, this will be number 2, this will be number 3. So it's on the second branch. That's why we'll have 2 at the beginning of the name. So please, guys, keep that in mind. It's very important. Okay, if it was maybe here, we would have 3 at the beginning of the name. Okay, and if it was here, we'll have 1. Okay, so keep those things in mind. I hope you understand. I hope you understand this part. So let's go to let's look at this. Homologous series is a group of organic compounds that can be described by the same general formula, and where each number differs from the next by the CH2 group. So let's look at this homologous series. For haloalkane, the prefix is bromo, chloro, fluoro. For ester is meth, is ethyl, is propyl. You see, so those are the prefixes for only haloalkane and ester. So for haloalkane and esters, you will not use these prefixes. Okay, so we only use these ones for haloalkanes and esters. So remember, keep that in mind. And then step 4 is to identify any branch group. So a branch group is that one that I've just shown you, that C that will be in the middle, just disturbing the pattern that the C's in the parent branch have done. So that is a branch. Name the branch to group by counting the number of carbons in the branch group. This group will all end with YL, methyl. Because they have a branch, they will have thiol, ethyl. Okay, note the position of the branch group of the main carbon chain. If there is more than one of the same type of branch group, then both numbers must be listed. Okay, followed by D for 2 branches or 3 for 3 branches. So if we have 3 branches on the main chains that are going out, the C's that have the C's in the parent chain that have other things, other branches, we are going to name the number of branches. Okay, followed by the D for the 2 and 3 for the 3. So if the molecule is an alkane, the branch group must be on the carbon with the lowest possible number. So alkanes, the branch group must be on the carbon with the lowest possible number. So the branch group must be listed before the name of the main chain in alphabetical order. Now we're going to go on the naming of haloalkanes. When naming haloalkanes, the halogen atom do not get prefix over alkyl groups. So numbering should start from end nearest to the first substituent. So guys, let's go into naming. I think we have shared enough of this theory. Now let's see some practicality. So here we are. This is the question. Give the IUPAC name for the following compound. Let's see what this is. Number one, solution. Let's see. Note the numbers attached to the carbon atoms would not normally be shown. Yeah, those 1, 2, 3, 4 will not normally be shown. So it's just for example purposes. You will have to do it yourself. So you will have to identify the functional group. That's number one. Functional group, that's what says if this is a haloalkane, carboxylic acid, ester, or an alcohol. But by looking at this, we only have single bond, carbon, and hydrogen. So this is an alkane, okay? That is how you identify it. First, you know this is an alkane, so the name will end with ANE. And then step 2, find the longest carbon chain. So here we have the longest carbon chain. Now with the longest carbon chain, you will have to know the carbons that make the longest pattern, whether it's going up or down or sideways. So here we have it. We have identified it. And then number the carbon atoms in the longest chain. So they have numbered them for you. It's 1, 2. So the functional group is just that it's a CH. Okay. So the functional group is wherever. You can start wherever you want. So we start number 1, number 2, number 3, number 4. We have 4 carbons in the parent chain. And then number 3 is said number the carbons atoms in the longest chain. Here we have numbered them. So the last one, look for any branched group, name them, and give their position on the carbon chain. There are no branched group in this compound. So combine, step 5 says combine the elements of the name into a single word. So we have 4 carbons in the main chain. That's but, and we don't have any branches. So the name will end with butane, A-N-E, because it's an alkane. Number 2, we're going to name we are still on the same, they're still doing the same example. But these alkanes have now a branch. Yeah, this is a good example. So you're asked to give the name for the following compound. So the step 1, identify the functional group. This is just double bond carbon and hydrogen. So this is an alkane. We just know by the structure. Find the longest carbon chain. We have in the longest carbon chain, we have 3 carbons. And then number the carbons in the carbon chain. They have numbered them. It's 1, 2, and 3. We only have 3. Remember that this one that is going down from number 2, it's the branch. And then look for any branched groups, name them, and give the position on the carbon chain. So there is a branched group attached to the second carbon, as you can see. In this case, the methylene group is on carbon 2. Regardless of which side you number the longest chain from. So this group has the formula of CH3, which is methane without a hydrogen atom. However, because it is not part of the main chain, it is given the suffix YL. The position of the methyl group comes just before its name. So because here we cannot name it like we did, we have a branch on the second carbon. There is 2. And because this branch, in this case, this branch group attached to the second carbon, in this case, the methyl group is on carbon 2. So for the if the branch is on the second carbon, we're going to do methyl. So it's 2-methyl, and then the number of carbons is prop. 3 carbons means prop, so we'll have 2-methyl prop, and this is an alkane. We'll have propane. That will be A at the end. So we have 2. The 2 represent the branch on the second carbon. We have methyl. When the branch is on the second carbon, it's methyl. And then we have prop because of the 3 C's in the parent chain. And then because it's an alkane, we have AN at the end. I hope you understand. Yeah, we have named them, but let's try a different one. We're still naming alkanes. Draw the semi-structure. Here they have drawn the semi-structural and condensed structural formula for the organic compound. It is 2.2.4 trimethane alexane. So we need to identify the functional group. The name ends with ane, therefore the compound is alkane. So you look at the what the name ends with, then you will know what is this homologous series, the structure of which homologous series. Then you have to determine the number of carbon atoms in the longest chain. So the longest chain has the prefix hex. So hex means that we have 6 carbons in the main chain, the parent chain. So you know that, okay, it has 6 carbons, and then we look for any branched groups and place them on the structure. So the compound is 2.24 trimethyl hexane. So we're going to focus on the trimethyl only. Therefore, there are 3 branched groups. So the first 2.2 means we have 2 branches on the second carbon, and the 4 means we also have a branch on the 4th carbon. As you can see in this example. So we have 2 2's before the name, so which means we had 2 branches. That one, that is CH3 at the top and the CH3 at the bottom, and then the 4 means we also have a branch on the 4th carbon. So that's what the beginning numbers mean. And it's trimethyl when we have 3 branches. Trimethyl for 3 branches, methyl for 1 branch. Okay, let's name an alkene. Give the IUPAC name for the following compounds. Now we have, this is the structure. The functional group is between C2 and C3. That double bond carbon is the functional group of an alkene. Okay, so the compound has a double carbon. Number 1, you identify the functional group. The functional group is the double carbon bond, and then find the longest carbon chain containing the functional group. So the functional group is a double bond, so the longest chain must contain the double bond. There are 4 carbon atoms in the longest chain. So 1, 2, 3, and 4. So we have 4 carbon atoms in the longest chain, and then number the carbon chains. They have been numbered, and then look for any branched group and name them and give the position on the carbon chain. There are no branched groups here. And then combine the elements. So we have 4 carbons, that's bute. We have combine the elements of the name into a single word in the following order. Branched group, so you need to name them as, you need to know the branched group. First is number 1, branches, and then the prefix, and then name ending according to the functional group and its position along the longest carbon. So as you can see here, we have bute for the 4 carbons, and then we have 2, we have 2 for the double bond, and then we have En for the end of the name because it's an alkene. So we have En. Or you can still, they say you can still write it as 2 slash butane. You see, that is how you do it. Draw the structure and molecular formula for the organic compound. So here we are given it ends with En, so we know that it is a En. And then we have the double bond is, that one means the double bond carbon is on number 1, as you can see here. And then we have the but. But means we have 4 carbons. And then we have the methyl, meaning we have branches. Okay, so that just means that we have branches. So we have branch, it's meth. Remember, meth is 1 branch. We have methyl. Methyl is on, it means 1 branch. Okay, so we have a branch on the 3rd carbon. So this is the branch that we have on the 3rd carbon. That's how you draw. And then let's move on. And let's name the alkynes. So how to identify the alkynes? The functional group is the triple C bond. That's highlighted in C. That's the functional group. So identify the functional group. There is a triple bond between 2 of the carbon atoms. So this compound is an alkyne. The suffix will be YNE. We've identified what this is. Find the longest carbon chain containing the functional group. So there at the top it is. Don't take note of, leave out the branches. Number the carbons in the longest chain. In this example, you will need to number the carbons from right to left so that the triple bond is between carbon atoms with the lowest number. So you will start from the right to number. Remember, you number 1 closest to the functional group. So the C on your right will be number 1, number 2, number 3, number 4, number 5, number 6. Going that way. That is how you will number this one. So you will start on that C close to the functional group. There are 3 on this, 4 on this other side. You're not going to start with those ones. Start with this one that is C surrounded by H's, and then the C that does not have anything, and then the triple bond with the other C. Start with that one on your right hand side. That will be number 1, number 2, number 3, so that you don't have to it's advisable to do so. It's advisable. We'll see why. The functional group is a triple bond, so the longest chain must contain the triple bond. There are 6 carbons, so the prefix of the compound's name will be hex, and then number the carbons in the longest chain. The suffix for the compound the suffix will be 2 ane. So we have the functional group there on number 2. Yeah, this is what I meant when I say you have to start giving the number from the one closest to the functional group. So this is how you will number them. Look for any branched group, name them, and assign the number of the carbon atom to which the group is attached. So there is methane, a group attached to the 5th carbon. So we have a branch that is on the 5th carbon. So in the 5th carbon we have methyl as well. So remember, we have numbered the carbon atoms from right to left. So because the branch is on the 5th one, we're going to have 5 methyl hex because of the 6 carbons, and then 2 because of the functional group is on the second carbon, and it ends with ane because it's an alkane. So here I'm going to do this. You can go through it. I think you now get it. So try to go through this by yourself. Let me show it properly. So this is the question. You need to give the name. Here it is. So the functional group is both on 1 and the 5th carbons. So it's 1.5. Yeah, I hope you recognize that. So if you are given the name how to draw, you are going to start with 6. So there is only one branch at number 6. By looking at the name, that's first 6. The branch is on the 6th carbon, and then you have 3 in the middle. That 3 indicates that the functional group is on the 3rd carbon, and then ane, okay, this is an alkane, and then that hept means that we have 7 carbons, but they're not going to test you on that now. They've just ended it on 6, so we can just let go of that. Now I told you about hydrocarbon, saturated and unsaturated. So the first 3 that we've just named are hydrocarbons. Now we can name haloalkane. Now the haloalkane is identified by that Cl. So there is a halogen atom and no other functional group. There is a halogen atom and no functional group. This compound is therefore a haloalkane, and will have the suffix of ane. So because of that Cl, when a C is bonded with Cl, that is a haloalkane. Just know that. So we're going to find the longest carbon chain containing the functional group. There are 3 carbons in the longest chain containing the halogen atom. The prefix is prop. So for 3 atoms, we have prop as the prefix. And then number the atoms in the longest chain. We have 3. And then name the halogen atom and assign the number of the carbon atom it is attached to. So we only have 3. We can name it in either way. So it is attached to the second atom. It's attached to the second atom. So we'll have 2 at the beginning. This Cl is attached to the second atom. And then chloropropane. Remember that I said haloalkanes can only have this following prefix. We can only have bromo, chloro, and fluoro for haloalkanes, and for ester, Smith, ethyl, propylene only. You can either choose from the 3 for haloalkane. So we will have propo. Propo means prop. Prop means 3. So it can either start with those 3 suffixes before we count the number of carbons. Bromo, chloro, fluoro, you can choose between those 3, and then that's when you will use count the carbons is a prop. And because it's a haloalkane, it ends with ane. So that's how you name this one. Let's see this one. Give a IUPAC name for the following compound. So there are 3. Identify the functional group. There are 3 halogen atoms and no other functional groups. This compound is therefore a haloalkane and will have the suffix an. There is Br, there is F, and there is Br. So we just have oxygens, so not oxygens, carbons bonded with either F, Br, or and 2 Brs. They can also be written as X. Find the longest carbon chain containing the functional group. There are 4 carbons in the longest chain containing all the halogen atoms. The prefix for this compound will be but. So there are 4 carbons in the, so that it means it will have but. And then you need to number the carbon atoms so that the halogen atoms are on the carbon atoms with the lowest number. So we'll start with the Br, the C bonded with Br only, and then that will be number 1. Number 2 will be the C bonded with H on the bottom and H on the top, and then the second C will be the one that has F on top and Br on the bottom, so that we can just have 1 and 1.3 at the beginning of the name. And then and that's how you name this. So the 1.3 is for the functional groups. They're on the branch 1 and branch 3. And then the diboron, the D will be for 3. We have 3 functional groups for the Br, 2 Brs and F. And then we have bromo. The name has to start with that. Are we still here? Yeah, we have 3. Here there are 2 halogen atoms that are bromine atoms and 1 that is fluorine. So we have bromine and fluorine, and then so 2 are bromine and 1 is fluorine. The F is fluorine, the Br is bromine. So 1 bromine is attached to carbon 1 and 1 is attached to carbon 3. So the fluorine atom is attached to carbon 3. So you have 1.3 dibromo and 3 fluoro. So on the first bromine have 1.3. It's on 1 and 3 branches, and then it's on 1 and 3 carbons, carbon number 1 and carbon number 3, and then we also have fluoro on carbon number 3. So that's how you write it. And there are no branch group in this compound. So the name of the compound is 1.3 dibromo 3 fluorobutane. I'm going to link a video in the description box of another YouTuber that has done this, so that you can go through it with them as well. So we'll end here on today's video. This is long. Thank you very much for watching. I hope you get it and understand how naming goes. We still do haloalkanes, carboxylic acids, and ester in a more detailed way in the next video. Thank you very much for watching. Until the next time.